Hi, it's Gadget UK here again. End of a long journey. I've successfully got this working at 16 megahertz. I need to tidy this board up a bit. As you can see, I've got caps sort of all over the bloody place at the moment. That cap needs moving, lead shortening. I need to shorten all these wires here. I'm going to put a switch on the AS line so that I can enable and disable this so I can run at 8 megahertz stock. It'll still boot, I think, when it initialises, and no, it should be alright actually, as long as I've got the insertion, the AS pin, not connecting. You know, it's, I'll put it through an AND gate. There's a spare AND gate on the 08 chip, 74F08. But as you can see, from my last video, I've got a chip removed there. Exos sent me, sorry, it's not Exxon, he's not a petroleum company. Exos, yeah, I must stop calling him Exxon, sent me, and has uploaded to his website a revised version of this. I think the initial one had a bit of a glitch. He mustn't have realised that at the time when he gave me that first diagram. So yeah, I could remove, I think it was the 02, 74F02, I forget now which one it was, I think it was. So I could remove that, and yeah, I'll show you the diagram afterwards. But as you can see, this is working. It's just on the high score there for Ghouls and Ghosts, Ghosts and Goblins. Let's just go down. Interesting thing with this game, I swear this used to be a bit jerky, and so I'll see if I can do this with one hand. If I just scroll, it just feels a lot smoother. It feels much more like an Amiga experience. You don't get massive performance, you know, increase here. It's like something like 33% on average, because what's happening is when the CPU asserts, you know, the bus, you know, for RAM and ROM access and stuff, it runs at 8 megahertz. So you know, you only get the 16 megahertz boost when it's not, you know, accessing the bus effectively. But you know, from what Exos was saying, that speeds up, you know, integer division and stuff, and probably a few. I would think there'd be a few other opcodes that that would work on as well. I'd be sceptical to think that it'd be just integer, where, you know, there must be other opcodes that work register to register. I guess it depends on how the program you're running has been coded to a large degree, but all of the games I've tested work okay. I think there's just one. I can't get Gauntlet running, but I've tested like Buggy Boy, Altered Beast, Bubble Bobble, Frontier, Elite. Oh God, you know, I've tested it at Last Ninja. I've tested a good 40, 50, 60 games easy, and they all work. Yeah, even Op Wolf seems a bit smoother, because Op Wolf was always one of those that struggled a little bit performance-wise. So really pleased with this. I'll just switch this off. I'll show you something else I've done as well. I need to tidy this up. I'm going to shorten these legs, put some heat shrink around these as well. At the moment, this is just a temporary thing here, and this was, if you look at Exos's website, I'll stick a link on the video for this, but this is the DMA chip, and it's the -38, and whilst this was never reported as being having any DMA fault on the STFM, by the time it went to the STE, obviously there was the DMA bug, which is quite famous. You know, it hit as the STE was launching, and there were all sorts of problems with hard disks. It corrupted hard disks. You know, you could boot from them as soon as you start to write. I think it screwed the disk up, partition table or something. But yeah, that was the sort of, there's a history behind that. It's worth researching it. It's always been a bit vague. You know, there's been a lot of people, including Lotharac, you know, the guy who manufactured these HXC cards and the Ultra Satan. He did some work on this, and Exos has done an awful lot of work on this himself as well. And if you look at his site, he's got an article on this. If you look at the hard disk bit where he's I forgot what it is, his gigafile or whatever it is, you know, he was having some problems with that, and he came to the conclusion, and I think he's right, because he didn't just do it on his one STFM, he has several. You know, he was messing around with several different ones, and he found pretty much the same problems with all of them, and even when he swapped the DMA, he still had a bit of an issue. So I don't know whether it's, I'm not saying there wasn't a DMA problem with these, but there was, I think certainly from what Exos is saying, a board problem. The way the DMA line runs right across the board or something. It's I suspect it's going to be one. It's one of these. You know, it sounds like bad board design, where you've got you know, the trace, the signals on one trace affecting the signals on another at various points in time. So yeah, putting something like I think you said a 360 or 380 picofarad cap across from ground to that pin. It's not pin 4, is it? I don't know how many pins this is. It's the 4th pin from the right there. Stops the not detecting the hard disk on boot. So that's not quite the DMA problem, but there is another cap you can put somewhere else to fix the DMA problem. My board revision is different to the one on Exos site, and I don't have any problems with the hard disk in general, other than very, very occasionally it won't detect the hard disk when it boots, and this seems to have fixed that. So it's worth doing that. Anyway, I'll fix the switch now. I'll show you the end result. Right, after a fair bit of messing around, as you can see, I'm totally on the home stretch now. I just need to reassemble this. I've shortened all my wires. This here, I'll upload a separate video for this to show how I repaired this, but I don't know if you can see, I broke the clock pin off. It's, it's one of those, if I got the board right from start and knew exactly what I was doing, that wouldn't have happened. The pin would have been bent out and I would have connected the clock pin up. But this has been in and out, in and out, in and out. I've been messing around with the board, bending the board over so many different times, It's like I said, this must be the 5th board revision, and I've done all sorts. I did mods to the original design that used the flip-flops. Because I've not got a scope with a digital sort of storage and stuff, it's very difficult. I could have got my dangerous prototypes, what's it called? Logic. It's actually a logic sniffer. It's a logic analyzer, effectively 16 channel. I could have got that on there, but it's a PIC-based thing. It's not very accurate. I've used it a few times in the past, and for things like this, you don't always see where you get bits of noise and stuff on there. It doesn't always register as a clock signal, because some of this old technology is more susceptible to the spikes and things, whereas something like that PIC thing, it doesn't always pick it up. But if you've got a proper logic analyzer, you'll get all the little bits and pieces. It's almost like a digital oscilloscope with the storage and stuff, and all the stuff that you get with a logic analyzer built in. So anyway, I'm rambling on. As you can see, what I've done with this, I cut a piece of clear PVC. It's actually an old CD case. This stuck a couple of pieces of double-sided tape onto those 2 chips, and shortened all the wires, so there's no real room for it to move around. It's not going to shorten anything, and the main thing is the underneath of that is isolated from the chips and the board below. So the other thing I've done is add this. I don't know if you can see this switch here. So it's going to go next to where the MARPET switch goes. I'll have the MARPET on the left and the CPU on the right. Need to route all that through the shielding and stuff yet. That's going to be a bit of an interesting one. But yeah, there should be enough, and I've left a bit of space here for 16 megahertz to just sort of fold that under. I should be able to shut that can like that, and as long as I don't snag the wire, I might even put a bit of tape under and over that just to stop it from shorting on there at some point. But yeah, it should be okay. Physically, it should fit in there. One thing I'll have to do is probably just trim the corner of that, because you can see there's a little hole there where one of the case posts goes through. So I'll probably just I'll just snag, cut a square corner off there. That should be okay. And I'll just bend this sort of in a little bit and down a little bit. It's not gonna move around. It's pretty it's held pretty well by the wires there. There's no way, it's not near anything to short, so it should be okay. But yeah, I'll switch this on. It was running in 8 megahertz, so I'll switch that back to 16. It's not going to short or anything, is it? Just make sure I've got nothing shorting anywhere. So I'll just put this back on the tripod while I film this. As you can see there, it's coming up CPU 133%, display 125, average 127. And if you look at the integer version there, 195%. As you can see, there's a small impact on all of these things. Some of them are, like a RAM access 101%, very little. Floating point maths 119%. Some of these are the result of the graphics stuff. Some of that's going to be my blitzer. In fact, the blitzer's not switched on. Let's check the blitzer. Test all that again. I'll jump to the end here after I've redone this, but I'll show you with the blitzer on. This is actually working with the blitzer. It's the MARPET that I was having a problem with. It took me a while to work it out, but after I went into like extra RAM or something to a test, and it was saying I had half a meg. It's like, what the hell's going on here? So I realised it was just the A9 pin's a bit loose. I need to bend it a little bit, put some heat shrink on the actual wire that's going to it. It's just the way, it's hard to explain, but it's the way because I've been shifting all this stuff around. it's just the particular pin that goes into the actual connector there came a bit loose, and that's what it is. It seemed to be intimately making a connection. But this was with the blitter enabled. Interesting thing with this benchmark software, as you can see, this version, I'm going to try different versions because I've seen the figures, you know, vastly different on other people's machines when they've used different versions of this. So you know, there are differences between versions of that software. As you can see, the CPU's dropped down a bit, and the averages dropped down a bit, and the displays dropped down a bit, all as a result of using the blitter, which is quite funny, really. I mean, the inter-division's even dropped. It was 198, now it's 194. It's almost like when you enable the blitzer, it kind of counters the benefit you get from the 16 megahertz. Very strange. That might not be the case with newer versions. It might shoot up. I honestly don't know. Yeah. Anyway, for the most part, that seems okay. Stable. Games are running everything. So I'm just going to reassemble it now. So just a couple of things here. As you can see, I've cut the corner off that. That's pretty much going to stay in place. I guess I could support that with some hot glue at some point, but yeah, I'm inclined to just leave that as it is. Really, it's okay. It's not going to move. Some heat shrink over the two caps there. I used a 200 picofarad and a 100 picofarad in parallel there, so you know, the add up, it's a bit like doing resistors in series. So that should be about 300 picofarad. I think Exos's original spec there was something like 360 or 380. It was a bit higher, but I mean, it's working okay. You know, it's booting every time. It's detecting the hard disk, so I'm happy with that. And this was the problem I just mentioned a minute ago with these pins. One of the pin, I don't know if I can show you. If I just pull this out, pull this off rather. God, it's not easy with this hand. You can see one of the way I did this with the A9 switch. One of the pins goes into the socket there, and as that is now, it's just wiggly. Do you know what I mean? It's really loose. It's not a good fit. So it needs this other pin here bent a certain angle so that when you push it in, it sort of forces it a slight sort of curve. As you can see, the two press against each other there, and I isolate them with heat shrink so they won't short, but it just bends it enough and holds it. As you can see, it's bent at an angle like that, just a little bit, and just make sure it's a good connection. And that was the problem I was having there, where it was intermittently A9 was intermittently sort of open circuit effectively, which was causing me those weird things with the blitzer. Strange how it only affected the blitzer, but you know, like I say, I did the way I narrowed it down as I started testing other apps and things, and started getting some weird stuff. And then I went into the memory tester and realised it was saying it was only half a meg. I thought, okay, well that's clear indication there's something going on with the MARPET there. So I'll just finish putting this back together. There you go. There's the old. There's results with the old version of this Gen Bench. So as you can see, CPU 132%, average 122. If I did that without the blitzer on, obviously it comes up 133 on this particular revision of this software. But I will test it later with a proper version. But as you can see, all working. Really pleased. This is worth pointing out. Actually, this is one of the side effects. If you've got any sort of raster type graphic games, you know that. You know, this is a good example. The hard disk ones, the hard disk adapted games done by PP. He has those. He has like a raster title image, you know, showing you the box art and stuff. And it won't display right because it's timing based. But yeah, as you can see, games work. Let's just see if we can start this asteroids. See what this is like. So I just thought I'd show you a few things here. I mentioned a few things as well. The CPUs I originally used were the 68HC00P16s. So the 16 MHz chip with cache, and those chips do not work in my revision of ST FM. I've got a revision C board. I've heard of people getting those chips working. Obviously the cache can cause you problems with some apps, so it's one of those, you know, you really need to just suck it and see really. I can't guarantee if you get one of those MC 68HC00Ps, whether it's the 16s, whether that's going to work. But I ended up with 68000P12, which is a 12 MHz chip. Sometimes they're stamped 16 MHz, sometimes they're stamped 12 MHz, but they'll all run it generally at 16 MHz. And I've proven that with this one. It's rock solid stable. When you're removing the 68000s to put a socket, be really careful. As you've seen in one of my earlier videos, I mangled the chip totally. I mean, it's many years since I've taken anything off an ST board, and I've never really liked ST boards versus Amiga boards. I find it easier to get things off an Amiga board than an ST board. Could be that ST boards are actually better manufactured, and the heat dissipation, you've got to have a higher temperature. I honestly don't know, but I mangled my CPU, so be careful when you put a socket on there. Yeah, so just to show you some of the diagrams, let me see. You've got 68,000 pin out here. This is useful if you've not got one to hand, I guess. Just to mention, you got, if you want to tap the power from the CPU itself, you've got your 5-volt VCC. You've got your ground pin 16, and bang in the middle there's your clock pin. As I previously mentioned, I snapped the clock pin off this 16 MHz chip. So I'll show you later how you can repair that. If you have a pin that's just completely gone and you can't get to it, you can Dremel it. You can Dremel the edge of the ceramic here and get down to the copper. And that's exactly what I did. And it's not, it doesn't look great, but to be honest, it all works. And I'm reluctant to just bin it just because of that. So I'm happy with that. I've managed to salvage that. You've got your BG pin, pin 11, and your AS pin, pin 6. And I guess just to explain how this works again, the AS pin is what it used to the address strobe pin, and it uses it when it's asserting the bus effectively. When that pin goes high, is effectively what it does is it downclocks it to 8 MHz. So whenever you're not accessing the bus, this mod now makes the CPU run at 8 MHz, and whenever that goes low, your CPU's just operate, processing instructions internally. It's not doing anything with the bus. Then it'll zoom up to 16 MHz. So that's the top and bottom of it. Let's see if I can find the original diagram. There's a diagram from original clock, pinouts. Yeah, don't use a separate clock. That was a stupid mistake. And on the very, very early videos of this, I talked about that when I actually received this clock in one of my pickups videos, this oscillator, and I was like, well, I don't think I'm going to. It might be a problem because you're not going to, it might not be synchronised with the system clocks, and that's exactly what it is. You've got to take the 16 MHz from the board, pin 39 on the shifter chip, as I've showed in the previous video. Yeah, this was the original schematics, the original diagram, and I apologise for the red. Highlight a penny of this is, I did this as I went along, so I knew which line, which tracks and things I'd already wired up. This uses a D dual flip-flop of some sort. I forget the exact name, but the problem is with this, and Exos, if you look at Exos' website, he's explained this in more detail, but I did see this a little bit with what I was able to capture on my scope. And that was the fact that the transition back from 16 to 8 MHz when the assertion changes back over, it's not instant, and you end up with you end up with a different frequency. It's not running at 16, it's not running at 8, it's something sort of in between. It can even be, depending on which side of the edge the edge lands on, it can even be faster. You could be 20 MHz or 30 MHz or something, especially when I was using an external clock. And incidentally, when I was using an external clock, this mod actually did work for about 5 seconds. So, I could have been lucky with that, and it was consistent. Every time you switched it on, it would boot, it'd get about 4 or 5 seconds into the boot, and then it would crash. But I don't think that was to do with having an external clock. I think that was to do with this flip-flop and the fact that these gates were not fast enough and it wasn't switching back after the assertion had gone low. So, it had gone higher, whichever way around it was, I forget. Yeah, so that's the original diagram. That doesn't work to my knowledge. Some people have got this to work. It may depend on the quality of the components you've got, the speed, the ratings of those components as well. If you're using HC or LS, it might not be fast enough. If you're using F, for these gates here, it might work. I honestly don't know, but just if you check out Exos's website, you'll see the technical details of that really, and why he couldn't get it working, and certainly why I couldn't get it working. Pinouts, I've shown these before. Obviously, for each of the chips you get, make sure you get one of these diagrams just to double check the pinouts. And it was worthwhile doing this because at the time when I did the original 4-chip mod, this mod from Exos, there's an 00, an 02. You have to ignore the codes on these. They're all, as I mentioned in the previous video, they're all Fs. So it'd be 74F32, 74F00, 74F02, and an 08 or whatever. But the 02, I think it is, if you check the pinouts on this one, if you look at this one, for example, you've got VCC, and then you've got input, input, output. Or this one, you've got VCC, output, input, input. So this 02 didn't fit with the same pinout standard that you've got in these other chips, despite the fact that it's got the same number of inputs and things, which I found a bit odd. But if I hadn't checked that and just assumed they're all going to be the same, I would run into a problem. So I'm glad I spotted that. As it transpires, the O2 was causing the problem anyway, because Exos produced this diagram. Again, apologies for lines all over it. And you've got a 32. Sorry, again, it's the same thing with the codes. I think the simulator that Exos designed this in, tested it in, doesn't have entries there for the F chips. It's only got LS and a few other types. So it'd be a 74F32, 74F00, 74F08, and then you're just using the same gates within those chips. So you end up with 3 chips. It's a 3-chip solution. That works really, really well. Other factors here, something else I wasn't aware of that did, I think, cause me some problems on the unused gates in the chips, the 3 chips you got on there. If you don't tie them to ground or high, I think the recommendation actually is to tie them to +5 through a resistor 4K7 or something. But anyway, pulling low works fine. If you don't do that, these become unstable, I should say. And from what I understand, from what I've read, and I was totally unaware of this, that they end up acting as sort of receivers, effectively. Any noise or any high frequency that's sort of floating around that area, can make these start to oscillate, and that can that will cause you problems if one of these starts oscillating because of a 16 megahertz signal or an 8 megahertz signal or some other noise nearby. You're going to start getting some weird stuff going on, because they're going to what's produced on one of the gates can start to cause problems with other gates. So yeah, you've got to tie those to ground. I wasn't aware of that. That's something I've learned. Really pleased to Exos for pointing that out, really, because I could have spent a long time messing around with that. As it transpired, it was pretty quick, really. His response was almost immediate when I said that I'd had these problems, and that was one of the first things he suggested I tried. But this mod didn't work. Sorry, not this mod. The original mod didn't work, and it was something to do with this LSO2. You got an extra level of inversion going on between the output of the 00 and that. And I did wonder about that at the time. I was like, okay, let's invert, and then you're inverting it again. But the output, this 8 megahertz is not inverted. So I don't know. I did question that in my mind. I could follow this. I can understand this. It's not a massively complicated circuit, but by the time you come to the output stage here, it could be a bit complex depending on how you look at it. What else was I going to say about this? So the only revision I've done to this is to allow me to disable it. You got the point on this section here that's used to switch, to force it to 16 megahertz, or go into the automatic mode where it's using the AS pin to determine whether it needs to be at 8 or 16. So that's not, as I said in my very first video, it's not a switch to switch the whole thing off, so it just runs at 8. But what you can do with this is, I'm trying to see them now, the AND gates. These 00s, that one's a NAND. Oh, sorry, it's a NAND. The 00 is a NAND. The 08 is an AND gate. And as you can see, there's only 2 of those AND gates used. So what I did is, I had the other 2 gates tied to ground. I changed that so that they weren't tied to ground, and put the AS pin, instead of coming into here, I put the AS pin going into one of the AND gates with a switch that either in one position will put, sort of +5 into the input, or through a 4K7 resistor, or on the other position of the switch it will ground it. So the idea being one of the gates is either going to be high or low depending on which position your switch is in, and the other pin put the AS signal, and then the output came into where the AS signal came originally. So the idea being that you're only going to get the AS signal coming in, and in fact it's inverted the way you'd think that would not work, but the way because it's got this inversion here, it does work. It's almost like the default is 16 megahertz, but it's the default is 8 megahertz and it's 16 megahertz depending on the assertion. So yeah, that works fine. Really simple, pretty elegant solution, really, because I didn't need to mess around with because if you look at the original diagram, where's it gone now? Here. Sorry, it's not that one. This one. Yeah, that was a BG actually. The BG was switched. I'm puzzled as to why. Maybe it's because the 2 are, yeah, that's an AND gate. So the 2 are used in parallel, so if you didn't have one, that's fine, that's the way that works. But the way mine works now is BG will still alter the clock speed. So I guess there's going to be some 16 megahertz stuff going on there. I'm not sure what BG is used for, we need to check that. But it seems to work anyway. Games that wouldn't run at 16 now run at 8. And vice versa. So Yeah, that's pretty much it. I hope you found that interesting. I'm really pleased I've done it, as you can, I'm sure you can tell. Been at this since about August or September last year, so it's, yeah, really pleased with that. I'll put some links to Exos's website. You must have a look at his website because he's done an awful lot of stuff on STs. He was a close friend of Alison Chalice. They worked together on the Pest and Jest and various other bits and pieces. So yeah, you must check his website out. He's got some great stuff on there. He's done a lot of different projects on the ST. You know, he's got stuff on there about the different memory upgrades. He's done, you know, a few different ones, different ways, including sticking sim directly straight on the board and produced his own board for different types of sims. He's done stuff on the floppy drive. He's got a 16 megahertz floppy drive mod where you can add a 1.44 meg sort of standard PC floppy drive, and you just need components from him to do that. It's like a crystal and a few of the bits, you know, a few of the components, and a new 16 megahertz floppy controller. The Western Digital, I forget the part number of those floppy controllers, but yeah, and he's done stuff on the hard disk stuff, the DMA fix as I showed on this. He's got a load of stuff on that. He's got some stuff, I think he's got something there too with the Falcon, I can't remember, some sort of 60 megahertz processor or something for it. I've not really had a detailed look at that yet, but obviously he's got this mod on there, and there's some detailed stuff. He's got pictures of the you know, the actual breadboard stuff. He's got the circuit diagram here if you want that. And he manufactures some of these things as well. We'll be doing an official PCB for this, so you know, if you don't fancy getting your hands dirty, you could wait and get one of those off him when the time comes. In fact, I'm going to order one off him anyway, partly in courtesy from doing this, but also because, you know, I'd like an original one of these. I probably won't stick it in here. I might just, you know, stick it on the side somewhere. I might even stick it in my ST if I can be bothered, mess with my ST. But yeah, anyway, thanks for watching, and I'll see you soon.